Hi everyone, this is Miss Yoon. In this video, I'm going to go over 2 of the questions that you were supposed to try on your own on the concept of calculating molarity. The first question was, calculate the molarity of 25 grams of KBr dissolved in 750 milliliters. And they gave us information 1000 milliliters is equal to 1 liter. First, let's just mark up what we want to find out versus what we know from the question. So it says calculate the molarity. So that's what we're going to be trying to look for. So molarity is what we're looking for. And what's given to us is 25 grams of KBr that's dissolved in 750 milliliters of a solvent. All right, so we know from the reference table for calculating the concentration or the molarity, it's the moles of solute divided by the liter of solution. So I'm just going to write that here. M is equal to MOL, moles per liter. All right, so now let's first find out the moles of KBr when you're given the grams of KBr. So what we're going to do is we're going to write down 25 grams of KBr and we're going to convert this to number of moles. In order for us to do this, we learned this in the last unit, is that whatever we don't want, the information that we don't want, is going to go on the bottom of the fraction. And what we want essentially is going to be the one that goes on the top. So the information of mole goes on top, and the information about grams of KBr goes on the bottom. All right, so for every 1 mole, we want to get how many grams of KBr that's going to be existing. In order for us to do that, we have to calculate the molar mass or the gram formula mass of KBr. And we learned this in last unit as well. Potassium has a mass of 39. So if we have KBr here, K has a mass of 39 grams per mole, and Br, which is bromine, has a mass of, if you look here, where is it? Bromine has mass of 79.9, which is approximately 80. So I'm going to put 80 here. 80 plus 39 is going to give you approximately 119 grams per mole. So I'm going to put that information here, 119 grams of KBr. Now, if you plug this into your calculator, it's just 25 divided by 119, which is equal to 0.21. So that's going to be, the unit's going to be in moles, because as you can see, grams of KBr can be canceled out because I see those units both on top and the bottom. So 0.21 mole of KBr is what we have here, which we are going to be using in order for us to plug that into that formula. Next, we're going to try to find out how many liters there are within the given information. So what we're given here is 750 milliliters. I'm going to use a different colored pen, and 750 milliliters, we have to convert that to liters. So whatever information we don't want is going to be going on the bottom. So every 1000 milliliters is equal to 1 liter. So milliliters can cancel out. So 750 divided by 1000 is going to be giving you a 0.75 liters. So you just have to move the decimal place over to the left 3 times. Okay, so this information is going to be the one that goes on the bottom of that formula. So now what we're going to do is just plug in. So 0.21 mole divided by 0.75 liters. And you plug that into your calculator, and it should give you 0.28. 0.28 moles per liter. Again, the unit of moles per liter could be also written as molarity, okay, as M. So the correct answer is the third one. Okay, so that was the answer. All right, let's now move on to the second problem. This was the last problem on the Edpuzzle. The question says, how many grams of KMnO4 are needed to make 500 milliliters of 0.200 molar solution? So I'm just gonna mark up some of the information that's given. We are given 500 milliliters and we're given 0.200 molarity. And we're looking for how many grams of this thing do we need, okay? So again, looking at your reference table, last page, the concentration, in order for it to calculate the molarity, it's given moles per liter. So I'm just gonna write that here. M is equal to moles over liter. All right, so let's just plug in the information that we know here. For sure, 0.2 m, capital M, is equal to mole over, and what's given to us here is in milliliters, which we have to convert to liters. So let's do that first. 500 milliliters, we want to convert that to liters, so I'm going to put that on the top. We want the milliliter information on the bottom. For every 1,000 milliliter is equal to 1 liter, so 1 liter is equal to 1,000 milliliters. So milliliters cancel. 500 divided by 1,000 is 0.5 liters. So that information goes on the bottom here, 0.5 liters. All right, now the question is asking for the grams of KMnO4, not the moles. So let's just first get the moles first by, if you cross multiply, so move that over. So I'm gonna write it here. 0.2 times it by 0.5 is going to give you the answer in mole. Okay. In other words, let me rewrite this here on the bottom. So 0.2 molarity could be also written as moles per liter. Okay. Is equal to moles over 0.5 liters. So in order for me to get rid of this 0.5 liters, I'm gonna bring that up to this side of the equation, 0.5 liters. Okay, so I can do that way and cross that out, and mole is equal to 0.5 liters times it by 0.2 moles. So liters can cancel out and you're left with 0.1 mole. Okay. All right. Now, from this 0.1 mole, we want to get to grams. So grams is what we want and moles is what we don't want. So for every 1 mole, how many grams of this KMnO4 are there? Okay. So we have to get the gram formula mass or the molar mass of KMnO4. So let's write that down here. So potassium, which is right here, 39 grams. For manganese, which is right here, is approximately 55 grams per mole. And oxygen, if you're not sure, it's right here, 16 grams per mole. But we have 4 of those. So 4 times 16 grams per mole is going to give you the molar mass. So let's calculate that. It's gonna be equal to 158 grams per mole. So that information is going to go on the top here. So let me just put 158 here, 158. 158 times 0.1 is equal to 15.8 grams. So that's our answer. And looking at our answer choices here, the correct answer is the third one. Okay, hopefully this clarifies some of the questions that you guys had. If anyone needs further assistance, please join me on Tuesdays and Thursdays at 11 a.m. on Google Meet. Okay, that's for a virtual help session. have a nice weekend, and there's one more extra problem that you can actually try. And also, there's gonna be a unit test next week. Okay, so make sure that you study and prepare yourself and make sure you know everything.